This is R.D. Sharma solution class 12 chapter 19. Exercises 19.12 indefinite integrals we are talking about. Now this one is sin raised 4x and cos cube x. Now what do you see here? Sin you can get cos, from cos you can get sin. How about the powers? So how are we going to write it? Sin raised 4x we will keep it like this. Cos cube x we can write it as cos square into cos x. Now this sin raised 4x, cos square x can be written as 1 minus sin square x, and sin square x plus cos square x is equal to 1. So cos square x can easily be replaced by 1 minus sin square. Cos x is already there. So we are going to put sin x as t. So when we place this sin x as t, this t is equal to sin x. The differential or differentiation of dt by dx will be cos x. Dx will go on the right hand side, so we got the cos x dx. This whole cos x dx we have achieved. Sin raised 4x will take t raised 4. This will be 1 minus t square. Cos x dx will be dt. So this is the integration. Let's multiply inside. T raised 4 dt minus t raised 4 into t square is t raised 6. So integration of this with dt. So this will be t raised 5 divided by 5 minus this will be t raised 7 divided by 7 plus constant of integration. And this t equals to sin x will be replaced because we have introduced it by ourselves. Sin raised 5x by 5 minus sin raised 7x by 7 plus constant of integration. This is your final result. So how are we going to solve it? This is the way we are going to go about it, and the logic I told you, but the written material should be like this. Now this sin raised 5x, we will encounter cos raised 5x, we will also encounter sin raised 7x, cos raised 7x. All those questions will be dealt in the same way as we are discussing just now. Sin raised 5x, this is 5. Now we have to see the power is odd. So we can separate it into one even and one odd. That is, we can write it as sin raised 4x into sin x. Now this sin raised 4x can be written as sin square x whole square. And sin x is already there. Now this sin square x can be written as 1 minus cos square x. You already know. Sin square x plus cos square x equals to 1. And sin x is here. Now let's open this. A minus b whole square, a square plus b square, that is cos square whole square, cos raised 4x. Now multiply the sin x also. So I'm just multiplying the sin x as I'm opening. So I'm multiplying sin x here. Minus 2ab. So minus 2 into cos square x. And this is sin x. Now let's integrate it. Now we're integrating it. Dx is already there. Just assume that it's all the term have they contain this dx in the end. So this you don't have to open it, because the I where I have written, you can do it here only. It will make it easier. How? Because when we place cos x equals to t, this dt by dx will be equal to cos x will be minus sin x. So dt will be negative sin x dx. So sin x dx will be negative dt. Sin x dx will be negative dt. This whole will be negative dt. So let's take this negative outside, dt remains here. 1 minus cos square x. So in place of cos x write t. So 1 minus t square whole square. That's why you don't have to do this step which I told you to open it up and multiply sin x. You can do it here only. So a minus b whole square, a square plus b square. So t to the power 4, which I wrote as cos raised 4x in the earlier discussion, which you don't have to do. So this 2t square I'm just bringing it outside just because we have multiplied it by negative. Negative was outside, negative dt, remember? So 2t square, 2 I am taking it outside, t raised power 4, and this is dt. So this dt will be integrated, means the integration will be in terms of dt. So t cube by 3, t square will give you t cube by 3, t raised 4 will give you t raised 5 by 5. This will give you t. So what do you get? So wherever t is there, you already got the answer actually. Just take this t and write cos x wherever it is. So 2 cos cube x by 3 minus cos raised 5x by 5 minus cos x plus constant of integration. So this is the better way to represent it. Multiplication of negative will make this solution. Otherwise, if you don't multiply it by negative, you will encounter that negative 2t square will come first. That we don't want. Now this is the solution, as I always solve and then try to give you the reference, because this is for writing. This is the whole way you are going to write. Now this cos raised 5x has come from where? Same thing. Sin raised 5x, cos raised 5x. The approach will remain same because the power is odd. So we can divide it into even and one of it as odd power. That means we need to write this cos raised 4x into cos x. This cos raised 4x will be cos square x whole square. Cos square x can be written as 1 minus sin square x, that you already know. Cos square x plus sin square x is equal to 1. So 1 minus sin square x whole square into cos x, already there, dx. Now when you put this sin x equals to t, you will get this cos x dx as dt. T sin x dt by dx will be cos x. So dt will be cos x dx. So this whole cos x dx will be dt. So this integration will become, cos x dx will be dt. 1 minus sin square x whole square, 1 minus t square whole square it will be. So 1 minus t square whole square, and that will be expanded just as we have done in the previous question. So let's open it. A minus b whole square, so a square plus b square t raised 4 minus 2t square. There is no negative. In the previous question it was negative, so we multiplied it by negative. That's why it has come as 2t square in the front. Now here we will solve it as it is. So integration of dt, integration of t raised 4, this will be integration of 2t square in terms of dt. This will be t, this will be t raised 5 by 5 minus 2 t raised cube by 3 plus constant of integration. Now t will be replaced by sin x. So sin x plus sin x to the power 5 by 5 minus 2 t cube will be sin x to the power 3 plus constant of integration. This is your result. Now this is the solution. It's almost similar to the previous question the way we have solved it. Only here we have to put t equal to sin x. In the previous question we have taken t equals to cos x. Now whatever we have done, see, it's so straightforward here. Because we can get the cos, we can get the sin, because sin has 5 power. So t equal to sin x if we place, dt will be equal to cos x dx. Already cos x dx is given here. Alright. So sin raised 5x can be written as t raised 5. Cos x dx is already dt. So you don't have to take anything. Don't bifurcate or divide. You will get t raised 6 by 6 plus constant of integration, which is sin x to the power 6 divided by 6 plus constant of integration. You can also write it as sin raised 6x. It's up to you. So this is the solution. It's very straightforward. You don't have to do anything. Sin cube x cos raised 6x. So let's separate them out, because right now it's very obvious that the sin power is odd, cos power is even. So this odd power, we can get one sin, we can separate one sin out along with their sin square. Cos 6x, we can have cos square x, cos square x, cos square x. So sin square x is equal to, we have sin square x and cos square x, but these are all even. So what I'm trying to suggest here is this sin square x and into sin x we can write like this. I'm just writing that separately because I want to get this sin x dx. Cos raised 6x can be written like this. Sin square x will be 1 minus cos square x. This cos raised 6x will be cos 6x. Let it be like that. And this will be sin x. See, only sin x, this cos x putting t, you will get sin x dx. And that is the whole idea of this question. Other things are just algebra. So t equals to cos x, dt by dx will give you minus sin x, negative sin x. So sin x dx is negative dt. So this negative dt will come here outside, negative dt. So it will be, integration will be 1 minus cos square x, that is 1 minus t square, cos raised 6x, and this will be t raised 6. And sin x into dx is negative dt. So minus will come outside, dt will remain here. Now let's multiply these two, 1 minus t square into t raised 6. It will give you t raised 6 minus t raised 8. So t raised 6 and t raised 8. So this will be t raised 7 by 7 and t raised 9 by 9. That's obvious. And still we have a negative sign here. So I'm just swapping it. T raised 8 will come first. T raised 6 will follow. So t power 6 will give you, t power 8 will give you t raised 9 by 9. T raised 6 will give you t raised 7 by 7 plus constant of integration. What is t? It is cos x. So cos x to the power 9, 1 by 9 it will be. So this is your final answer I'm writing. T raised 7 will be cos x to the power 7 by 7 plus constant of integration. This is your final result. So this is how you are going to go about it. Just you have to worry about the power. If it is odd, then you can easily see, oh, that can be divided. Now we have done cos raised 5x, sin raised 5x, and now we are on to cos raised 7x. This cos raised 7x, you know that the power is odd. You can get cos raised 9x also, but the only thing is it will take a certain time. So in order to judge that the students can solve it. This is the highest limit you can get, cos raised 7. So cos raised 6x into cos x we have written. Cos x dx can be easily achieved by just writing this as sin x equals to t. So cos square x is 1 minus sin square x. Cos raised 6x will be cos square x to the power 3, because cos square x is 1 minus sin square x. So cos square x will be 1 minus sin square x, and this will be to the power of 3. So this cos raised 6x can be written as an integral. This will be 1 minus sin square x to the power 3, and this cos x remains here with a dx. Cos x dx is equal to what? T equals to sin x you can keep. Dt by dx will be equal to cos x. Dt will be equal to cos x dx. This whole cos x dx will be dt. 1 minus sin square is 1 minus t square. So 1 minus t square whole cube. So this whole cube, if you know the formula, it's very good. If you don't know the formula, just multiply 1 minus t square 3 times. That's the only thing which you can do. Because a minus b whole square is a cube minus b cube plus minus 3ab a plus b. Okay, that is the whole formula. So 1 minus t square into 1 minus t square whole square. This is just to let you know that those students who might not recall this formula, for that they can just use say 1 or less than 1 minute to solve it. 1 minus t square is a minus b whole square. 1 minus t square multiplied by a minus b whole square is like this. So I am multiplying this 1 plus t raised 4 minus t 2t square by 1. Then I'll multiply this 1 plus t raised 4 minus t square with minus t square. And then I'll combine them, and you will see the formula. If you are in those category of students which know this formula already, then you will see that after doing all this, you will get the final result, which will be a result of expanding it using an actual formula of a minus b whole cube. So 1 plus 3 is 3t4 minus 3t2 minus t6. So let me write it in the way the power are written. Well, that's not a thumb of rule, but always it's trivial that we start with the highest power, end up with the lowest power. But we see that the negative should not come first. So negative t raised 6 will come. That will not be appreciable especially by the examiners. So for that, we will just keep it like that, whatever we get. So first one will be dt. So t raised 6 will be t raised 7 by 7. T raised square will be t raised 3 by 3. And t raised 4 will be t raised 5 by 5 plus constant of integration. So this t will be sin x minus sin to the power 7x divided by 7. This is the second term. 3 gets cancelled. It will be sin cube x. And this will be plus 3 by 5, t raised 5, which is sin x to the power 5 plus constant of integration. Okay, that's your final result. So this is the way you are going to go about it. This is the solution in front of your reference. X into cos cube x square into sin x square. See, this x square is more important here rather than cos and sin. Because x square, if you take this as t, you will get 2x in the differential, and which is already there in the question. So this x dx will be coming from x square. That is how you have to go about it. So how are you going to write it? Just write x square equals to t, or assume t equals to x square. When you differentiate this, dt by dx will be 2x. That means this dt will be equal to 2x dx. So this dt by 2 will be x dx actually. We already have a x dx in the question. And when we have this x dx in the question, we can just take these x dx and replace it by dt by 2. So dt is there. By 2, that is half. Then cos cube x square. So cos cube t. This is sin t. X square is t. Now how about it? If you take this cos as t, sin will come directly. Alright. So if you take this cos x equals to t or p, because already one assumption we have made, x square equals to t. So I am taking cos t as p. This dp by dt will give you negative sin t. So negative dp is minus sin t dt. Minus has gone on with the dp. So negative dp equal to sin t dt. So integration will become 1 by 2. This will be p cube sin t dt. This is dp. So minus half p raised 4 by 4 plus constant of integration. P was what? The first assumption, not the latest assumption you can assume. So p was cos t. So minus half cos raised 4t by 4 plus constant of integration. Still not done, because the initial was t equals to x square. So minus 1 by 8, because 2 and 4 is there in the denominator. So we have written minus 1 by 8. Cos raised 4x square plus c. This is how easy. So this is the way you have to do. Now, one more thing I can suggest you, that this T after P is what we have been using for years now. But if you want to change it to some letter which doesn't meet or doesn't say coincide with any of the letter in the question, like you can take K, M, N, all these letters are free, but not those which are there in the question. So this question I would like you to do it, but I'll be discussing it in the next discussion. Till then, thank you so much. Take care of yourself.